Hello everyone, this is James. I'm a computer science graduate turned teacher. In this video, we're going to look into A-level computer science chapter 3 hardware. And this is the chapter outline for this video. First, we'll look into the overview of a computer system, and then I will let you know what the concept of embedded system is. After that, we're going to dive deep into what each component in a computer system do. So let's look into what a computer system is. If a computer system has to support the following operational capability, it has to take in input of data and possibly process this data and store them into the memory, and eventually find a way to output it for the user to see. And I'm going to use the von Neumann architecture today as the backbone of this chapter, the big picture. So the von Neumann architecture is a computer design proposed by John von Neumann that incorporates a single memory to store both data and instructions with a central processing unit. Think of it as the brain of the computer system that can sequentially fetch, decode, and execute these instructions. So today in this video, we're going to look into the memory part and the input and output. And in chapter 4, we're going to look into what a central processing unit do and what it comprises. Let's look into first the storage of data, how data is stored in a computer system. So these are the following components that are used to store data. First, we have the processor components. To store data inside a central processing unit, we use registers, and there are many different types of registers that are used to store different data, but I will talk more about that in chapter 4. We also have primary storage, which include the cache memory and also the main memory, in which we're going to dive deeper into what they do in a while, followed by the secondary storage, which is your hard disk, SSD, and even auxiliary storage like your removable disk and CD. So to compare the different types of data storage components, I have created this diagram here. As you can see, the register has the shortest access time, meaning it takes the CPU the shortest time to access them, which means they are very quick. And then auxiliary storage has the longest access time. But with that, they also come with the highest capacity and size. Of course, with great access bit, and it becomes more expensive. So register here are the most expensive, and followed by cache, memory unit, secondary storage, and also auxiliary storage. So to illustrate, I found a few images on Google for you to see. So this is a 64 gigabyte RAM component that are sold online, and it costs around $500 US, whereas a 256 gigabytes SSD, which is in turn a secondary storage, it is a lot cheaper than what the RAM costs, which is the memory unit here. So this image is an illustration of how their capacity and cost can vary. Here I have also created a table to compare the function versus the hardware. So if you are picking a device to store data, you can use hard disk or solid state drive SSD to be the integral part of the system. So a storage device that is an integral part of the system. Whereas an individual storage object that can be placed, so which means it's not attached, you can use floppy disk, optical disk, magnetic tape cartridge. And the third one, peripheral device that can be connected to the system when needed, which means that you don't want a component that is always connected. Then you can use a hard drive or memory stick, a pen drive like this. Oh, I have it on my table. And a portable memory device that can be carried around will be, again, optical disk, flash drive. And if you want your storage to be removed from the system, which means not in the location where you are in now, you can use cloud storage and magnetic tape. So these are the memory components of a computer system. And we also have the output device, which output the processed data in a computer system like screen, printer, speaker, VR set, and also writing to data storage device like you are burning a DVD, that's output device as well. So where it comes through input device, here are the few input device like keyboard, touch screen, scanner, microphone, and even inclusive the mouse that I'm using now to control the computer system. And the keyboard is over here. And here you go. That's the overview for what a computer system comprises. And now we're going to move on into embedded system. So the computer system that we described just now, they are called general computer system because they can perform many different tasks like browsing, playing games, playing music. Whereas embedded system, they are called specialized computer system. This is because they only carried out a very specialized task, possibly only a single function. But they work almost the same way as a computer system. They have input, processor to process the data, and memory to store the data, and then output it to a device for this user to see. And I have a note here. If this system are built on a single integrated circuit, they are also referred to as microprocessor. So some examples of embedded system to help you catch it as a vending machine. So for your information, vending machine, they also take in input, the high-end one, and like what are you going to choose for your products to be purchased. That's when they receive your input. And then memory will likely be the drive that stores the price for each product. A processor, they can calculate how much you should pay and how much change they should return. And output will be an actuator pushing the product back to you. Another example would be washing machine. So the concept is very similar. The advantages of a embedded system is that because they are usually designed for a single specific purpose, they may specialize in executing just one function, which means that the designer of the program doesn't have to think too much about what it can do, what other things that it can do. And also due to economies of scale, these chips can be relatively cheap. All right. And disadvantages, in the past, the program has to be short because memory space available is limited. But in today's society, that's not a problem already. But we are facing a bigger problem now for embedded system because embedded systems are integral components of the Internet of Things, meaning more of these systems are being connected to the network. As a result, your device that has computer chips inside might not be so safe to use because it is susceptible to hackers. So that's embedded system. Now we're going to dive deeper into what each component in a computer system do. We're going to start off with the RAM, random access memory. So it is a type of computer memory that provides high-speed data access to temporarily store and retrieve data that the CPU can quickly work with during computer operation. And the keyword here is temporarily and also high speed. If we look into the diagram here, you can see that the memory device is very closely located to the CPU because they consist of data that the CPU needs to access very, very frequently. Of course, it's also known as direct access memory, which means that when the CPU wants to get data from the memory, they don't have to go through from like 1, 2, 3, 4. They can just directly accessing a particular data in the memory. So that's the first characteristic. The second characteristic of a RAM is that it loses its stored data when the computer power is turned off or interrupted. I believe that all of you have the experience is that when you're playing a game and then you have made a lot of progress, yet you forgot to save your program and the computer then crashed. And when you restart your computer, you found out that all your progress have been lost. And that's because all the progress that you make in the game, they're actually stored in the RAM. But because we know that RAM is temporary, if you didn't save your progress and the power is off, all the progress will be erased. So this is why game designer asks you to save your progress. This is when the computer knows how to store the data, let's say you progress in a game, from the primary memory, which is the RAM, into what we call the secondary storage here, which is permanent as compared to the memory unit, which is temporary. So RAM is also a place where your computer stores all the programs that you're currently running. This is why when you have a computer that has a big amount of RAM, you can open a lot of apps at the same time. But if you don't have that, this means that a computer will crash once you overpower them. So that's random access memory. And there are two types of RAM in your syllabus. First is called the dynamic RAM. is a volatile computer memory. Volatile means that once the power is off, it's lost. That stores data in capacitors within cells and requires periodic refreshing to maintain data integrity. It's cheaper compared to the another RAM, static RAM, and requires fewer electronic components per bit stored. Whereas the static RAM is another type of volatile computer memory that stores data using flip-flops, which is a type of logic gates, allowing faster access and lower power consumption compared to DRAM. And the benefit of it is that it has shorter access time. So expensive one is faster, and the cheaper one is slower. And the way you can remember which one is cheaper, my student once said this. Just remember it stands for dirt cheap, and then S stands for super expensive. So that's how I remember which one is the fastest, which one is the cheaper. All right. And then the SRAM here is usually used as a cache. Cache is a specific, think of it as a specific type of RAM that is inside the central processing unit that stored frequently used instruction. And then the DRAM is usually the RAM that your computer uses now, all right, outside of the central processing unit. Of course, we use SRAM here because it's expensive, and we wanted the CPU to access the data inside the cache very quickly as compared to DRAM. DRAM usually is bigger in size. This is why we use DRAM to save costs. So that's for RAM. The next type of memory component is called the ROM. It's only one character difference. It stands for read-only memory. As implied by the name, you cannot write data into the ROM. You can only read it from the data storage. It shares the random access or direct access properties of RAM. Used to store bootstrap program startup file, which means that it contains the program that your computer needs when starting up the operating system and all the application software. And the program runs immediately when the system is switched on. So while ROM is an important component of a computer system, it's not part of the core von Neumann architecture. And there are different types of ROM here. First is the simple ROM. It is installed as part of the manufacturing process. Chips need to be replaced if different contents are needed, meaning the content inside the chip is permanent, is set by the manufacturer, and you can't change it after it has been used. So the next level of a simple ROM is called programmable ROM. It allows program to be written to by a system builder once, like a programmer. So after installation, data becomes permanent. So with this, it's not customizable, but once you have done your customization, you can't change the data anymore, just like a simple ROM. This is when we have erasable programmable ROM, PROM. Data program in place can be deleted. So one set can be deleted using ultraviolet light, and then a new program can be loaded, but then the chip has to be taken out, which means you have to reset the stuff yourself. This is when we have another new level of ROM called electrically EEPROM. Not sure that's how you read it. But in this, instead of using ultraviolet light, electricity is used to remove existing data, and the chip can stay in a circuit as its content are modified. Think of it like a level 1, level 2, level 3, level 4 type of read-only memory. And the third type of memory storage components is what we call the buffer. Sometimes when data is sent from one computer to another, problem arises if data is sent more quickly than it can be received. The solution is to use a buffer. A buffer acts as a temporary storage and operates as a queue for data moving between system components. Think of it like a temporary storage device that stores data that will be used in a while. For instance, when you're watching YouTube videos, the video that is sent to you will be stored in the buffer while your computer is still playing the videos. Alright, that's it for primary storage, the RAM, the ROM, and also the buffer. Now we're going to move into secondary storage device, which is your magnetic media. The first one, your HDD. Magnetic media refers to storage devices that uses magnetic pattern, north and south, to encode and store digital data such as hard disk drive and magnetic tape. So let me explain how this works. The magnetic media here, the hard disk drive, has something called the read-write head. So the read head is a component in the magnetic media storage that senses and interprets the magnetic orientation, north or south, on the storage medium to retrieve the stored data, meaning north can be used to represent 1, south can be used to represent 0. And then the write head here is a component in the magnetic media storage that generates magnetic pattern on the storage medium. Meaning instead of reading the magnetic patterns, they generate the magnetic patterns to encode 0 and 1 onto the disk. So here are how magnetic media work. I'm gonna go clockwise. So all the plater, this here is called plater, rotate at a synchronized speed. So I have 3/4 disks here, and they all rotate at the same speed. And the movement of each read-write head is coordinated or synchronized with the motion of the other head. There's more than one plater in a magnetic drive, and there is a read-write head on each side of the plater, layer 1, layer 2, level 3, layer 4, and the actuator arm are responsible for attaching the read-write heads and enabling them to traverse the plater surface. So this will move around the plater to read data, like in binary. So let's look into what a single disk here represents. So a single disk here has multiple components. First component is what we call this track, a circular path on the HDD surface used to organize data. And second component is the sector, small storage device within track, typically 512 bytes, which is the purple color section here. And due to synchronized motion of the head, it's possible for related data to be stored on the same track across different disks. So remember, you have a few disks here, so it's possible for data to be stored across different disks. And block here, group of consecutive sector used for file storage and management, which is around here. Alright, so that's the terminology to describe the components within a disk. And when it comes to using magnetic media, sometimes a problem called defragmentation could arise. And here they said when storing a file, you need to allocate necessary number of sectors, but they may not necessarily be contiguous. Meaning if you are storing all this data, 0 and 1 here, they might not be with each other, next to each other. And if you have more data, like data number 2, the purple color, 0 and 1, they may be very scattered. And what happens is that as more files are being created, they become more and more scattered, leading to a degradation in this performance, because the read-write head will have to move a lot just to read one data, and that results in HDD being very, very slow. This is when a defragmentation software comes in. They help to rearrange how sectors are allocated to file, restoring this performance, which is from this, they organize it so that related data are arranged contiguously, and this is the final result. And hard disk is classified as a direct access read and write device, since any sector can be selected for reading and writing. So this is very similar to the random access and read-only memory that we just learned. So the first type of secondary storage device is the magnetic media. The second type is what we call the optical media. It is a storage medium that uses laser technology to read and write data on disk. And this is an amazing technology to store data like 0 and 1. And let me explain. The evolution of optical media from CD to CD that can allow you to write data, to DVD, and eventually to the Blu-ray disc. So how it works. For a disk, very similar to the disk on the HDD, it features a continuous spiral pathway that extends from the innermost part of the surface to the outer peripheral. So that's how data are being stored around here. And then during operation, the disk will spin. Simultaneously, the laser moves across, ensuring that it is continuously focused on the spiral track. But at this point, you might ask, how can a laser and a disk like that encode 0 and 1? And this is when the magic comes in. The surface of the disk contains features such as the pits and the LAN. And what happened here is that the pits and the LAN becomes a mechanism for the data to be encoded into the disk. So imagine that you emit laser here. Pits are interpreted as binary 0, and LAN here are interpreted as binary 1 in the digital encoding. And how do they do that? Because imagine if you have a laser light emitting to the LAN, it will take less time to travel back to be reflected. And with the amount of information, the computer reader will know that, hey, this is the 1 and this is 0. So this is how this works. So here are just some information about the CD and DVD. They use unique alloy material as their reflective surface. During the writing process, meaning encoding data, laser heat turns the material into liquid state. Remember, it will melt, right? Solid. The intensity of the laser determines whether the material becomes crystalline or amorphous when it cools. And during reading, laser light reflects from the crystalline solid but not a formless one, enabling the encoding of 1 and 0. Some of the property, despite having a single track, it functions as a direct access, meaning I can access the memory here, 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 here. And this is possible because the laser can move forward and upward along the track. Data on the disk is organized into sectors, similar to how data is formatted on a magnetic hard disk. So how do we increase the storage capacity for a disk? First, you can increase the speed of rotation, meaning that more data can be read and be written to at the same time. Second way is that instead of using a red laser light, you use a blue laser light, which has shorter wavelength. And when it has shorter wavelength here, you allow more pits and length to exist on the disk. As a result, you store more 1 and 0, enhancing the storage capacity. Alright, so that's optical media. Let's look into the third type of secondary storage device called the solid state media. It is a semiconductor technology that has no moving part. So as compared to hard disk drive, when there's a moving part to read data 0 and 1, it has nothing to move. And how it works is that I created this illustration. The amount of electrons in the circuit will determine what type of data is stored. For instance, if there are 8 levels of how much electrons can be stored, if I only fill electrons to level 3, it stands for 101. But if I fill it up until level 5, it stands for 011. And that's assuming that there are only 8 levels. So this is how solid state media is being created. So here are some of the terminology for a solid state drive. When you have something called like that, it's called a single memory cell. In this case, a single memory cell will store 3 bits. And when you group all the cells together, you get a string. In this case, it will store 12 bits. And when you group the string together, you get a page. And then when you group all these pages together, you get a block. So here are the few terminology: memory cell, string, page, and the block. So before writing data to memory block, the block's existing data must be erased. This unique capacity allows for erasure of an entire block of memory cell in an instant. So instead of using a read and write head like a HDD to change the data, all you need to do to change the data here is to release some of the electrons. Just don't store too much. And when data is reached, a single page of data like that can be read in one operation. This is why SSD here is a lot quicker than magnetic media. First, it has no moving part, and then erasure of data can be done pretty quickly. And I have a video here that I found is really a masterpiece to explain how SSD work. I've put down the link on the video description. Feel free to check it out. And okay, so here are some of the use cases for solid state media. My MacBook is using SSD, and then the memory card is also using flash storage, like flash memory. So this is when the technology of solid state media comes in. And then a solid state drive is a storage device. I believe that most of your computers are using this now. They are faster and more durable compared to the traditional hard disk drive like HDD. So while degradation is possible, it will occur gradually and can be identified and mitigated through corrective measure. So SSD, as compared to HDD, is lighter, more reliable, thinner. The key thing, faster in data access, and also cooler because it has no moving part, there's no friction, so there's no heat. So now we have looked into the memory components, like the memory unit and also the secondary storage. Let's look into some of the output devices that a computer system use to output data for the user to see. First one is the screen display. For your information, the screen that you're watching now, there consists of thousands, if not millions of pixels. And for each pixel, it comprises 3 subpixels and typically represent red, green, and blue color. Adjusting the brightness of this individual subpixel enables the display of a wide spectrum of color. So when you mix these 3 primary colors together, you get many different colors. So here's the evolution of how screen is. First, in the beginning, they used cathode ray tube. They use an electron gun to emit a stream of electrons. These electrons are directed and controlled by electromagnet to strike a phosphorescent, it's hard to read this, producing light here and creating the image you see. So that's the first generation cathode ray tube. But for now, most of us, we are using liquid crystal display or even LED. So now for LED, each pixel contains a liquid crystal cell, and LED backlight is being used to illuminate the pixel matrix. So this polarized light is directed at the pixel matrix, and a polarizer here is placed between the pixel matrix and the screen, and when voltage is applied to the pixel cell, it changes the liquid crystal molecule alignment. So this change in alignment alters the light polarization and the display screen content, which is what you are seeing on your screen now. So that's for display, but there's another type of display that is on the trend now, which is the virtual reality headset. Check out Metaverse. So a virtual reality headset is a wearable device that immerses the user in a computer-generated three-dimensional environment. So what you are seeing on the monitor now may be two-dimensional, but a VR set provides a three-dimensional environment that helps you to immerse into the environment completely. So that's for screen. What about text? In order to output text from a computer system, there are two types of printers we use, the inkjet printer and also the laser printer. The inkjet sprays tiny droplets of ink onto the paper, whereas laser printer, they use toner. So let me explain how this works. For inkjet printer like that, a sheet of paper is inserted and subsequently the printhead transverses across the sheet, applying ink onto the paper. And the paper is advanced slightly and the printhead repeats its movement across the paper, with the process continuing until the entire sheet has been completely printed. So the printhead is composed of nozzle that eject droplets onto the paper, and ink is provided to the printhead from one or multiple ink cartridge. So just remember the inkjet printer, they have a moving head, and then they spray ink onto the paper to produce the image that you want to see. Whereas the laser printer, they uses a mechanism like that. So the drum here, they have a photoreceptor drum. First will be charged electrically. The revolving drum is exposed to a laser beam guided by mirrors and lenses, meaning they will guide all this laser beam here, selectively discharge its surface at various positions, meaning the position on the paper. So this repetition creates a full page electrostatic image. Charge toner adheres only to the discharge area on the drum surface. And the toner will then transfer to a charged sheet of paper fused with heated rollers. And the drum is discharged before repeating the process for the next page. So typically, laser printer will be used in large company that values fast printing and high quality image. So they usually produce printed text that are of high quality than the inkjet printer. But the downside is that they are more expensive. Alright, and if you want color printings, you don't just need black toner, you also need the following three colors to be mixed and matched, so that you can print any colors you want from your documents. So the technology generate dots, and image quality is influenced by the dots per inch, which can be controlled by software to adjust the number of dots per pixel. So that's inkjet printer and laser printer. And the other types of output device that output text or even graphic is the graphic plotter. Unlike the printers, a graphic plotter uses, they are more precise. And it works by using pens or drawing tools to move across the paper. It's just like you have a person, an artist drawing on the paper for you. And they also provide vector graphics, which is what we learned in the last chapter, with consistent line quality, making them valuable in engineering and design application. So that's another output device in our computer system. And you also have 3D printers. So instead of printing a 2D paper, the 3D printer is able to create a craft work just like that, by printing out layer by layers what the final object is like. So I'm not going to go through it, otherwise I'll be reading throughout my video, which I don't really like. So next, input device. What are the devices that we use to give data into the computer? So first is the keyboard. So the keyboard here, all of us has one. So just note that each key here, once you press it, it will be converted to character codes, which are then transmitted to the processor. The operating system under its control ensure that the text character that you type in, like Q, E, will appear on the screen. So The keyboard incorporates electrical circuitry along with its own microprocessor. Inside of it, you can find a microprocessor and also a ROM chip. And here are some of the process that the keyboard goes through when it wants to recognize the key. Basically, every time you type a single key here, it'll refer to something like a dictionary to check out, oh, what character is this? And then it will be converted to binary to be sent to the computer. So it's something that you can read along the way. Next, another input device is, very importantly, our screen on your phone or your tablet. And a graphical user interface, when you have a screen, it allows user to control data input by providing different types of screen icon. So sometimes pointing device like a mouse or controller is needed. There are 3 types of touchscreen. First one is the resistive touchscreen. As implied by the name, they are not very flexible and they are not very sensitive. They have 2 flexible layers separated by a thin space. When pressure is applied, the top layer moves to make contact with the lower layer, creating voltage dividers in both horizontal and vertical directions. And the downside of it is that it's not very sensitive and they are cheaper. And so they are being used in shopping malls or even the kiosk machine that you see in McDonald's or everywhere. Another screen, the second type is the capacitive touchscreen, which is the screen used by phone manufacturer. They operate by detecting capacitance changes caused by finger touches on a glass screen. So projective capacitive touch technology uses multiple capacitance and featuring a circuit with an array of capacitor under the screen enable multi-touch. So this is the concept that Steve Jobs mentioned when he introduced the iPhone, meaning multi-touch means that you can touch at different locations of the screen and they will work simultaneously. So that's the concept of multi-touch. Look, so we have resistive touchscreen, capacitive touchscreen. They are the input devices. And you can also input graphics like what I'm doing now, I'm inputting my face into my camera. So camera and webcam, they can serve as a tool for transmitting video footage to a computer. While a digital camera can be linked to a camera to transfer and save photos or videos within the computer storage. So that's input of graphic. And you can also use a scanner if you want to. That's the contrast of a printer. So how it works is that it keeps a sheet of paper with the image stationary while a light source moves across its width, spanning from one edge to another. And they work by the concept of reflection of light and then guided by a system comprised of mirrors and lenses onto a charge coupled device. So here are some of the characteristics of a charge coupled device. They have a grid of light sensitive cell to receive the light, and each cell within a CCD generates an electrical signal that corresponds to the intensity it receives. And to facilitate communication, a CCD requires an analog to digital converter, meaning to convert the amount of intensity, let's say you measure it in some random units, you have to convert it to 0 and 1 so that the computer can understand it. So that's input of graphic using a scanner. Now, last but not least, we want to look into the input and output for sound. So for now, I'm using a microphone to record my teaching. But of course, input of sound are important in many other instances like video conferencing and also voice assistant. So when for instance, Siri. And usually the input device for sound is a mic like the one I'm using now. It requires a diaphragm that vibrates when it captures sound, captures its frequency and also amplitude, producing an electrical signal, which is 0 and 1. Condenser microphone, second point, use capacitance change or piezoelectric crystal for this process. Again, very much like the scanner here, an analog to digital converter is needed, meaning convert the frequency and amplitude of the sound it record into binary for the computer to understand. So besides input, you can also do output of sound. Usually we use a speaker or an earphone here. I have an AirPods, so that's an output device for sound as well. So this analog signal drive a coil in a magnetic field created by a permanent magnet within the speaker. So the changing current makes the coil move, which controls a diaphragm to produce sound. And with that, we have gone through all the hardwares for a computer system. We first learned about the memory devices, primary and secondary storage. And we also look into the input and output devices. And in the next chapter, what we're going to do is to look into the brain of the computer system, which is the central processing unit. And I will see you there. And thank you so much for watching. Goodbye.